Hello and welcome again. Today we are going to study about the measurement of power and power factor by using the wattmeter and also the power quality analyzer. You can see the experiment. Our aim is to measurement of power and power factor of RL and RLC loads, different loads. First we will study about the resistive loads. We are going to use only the resistive load. As you can see here, we have the input supply. We can vary it from 0 to 30 volts. It is variable supply. We will give this by the auto transformer. Then we have the ammeter here. You can see we have the ammeter here. Then you can see we have the wattmeter. This we have, as we have given already the demonstration about the wattmeter. As you know, we have 4 connections in wattmeter: M, L, C, and V. This is the pressure coil and the current coil. You know the current coil is static and pressure coil is moving. As you know, the in pressure coil we have two connections, that is between the supply side and the load side. In the current coil, it is the static coil. The one connection is on the load side and another one is connected on the supply side. Then you can see we have the voltmeter to check the output voltage. Then we have the variable resistor load. As we are going to increase the resistor load, we will see what will happen to the current and what will happen to the phasor. As you already know, the cos phi is equal to 1 in resistor load. As we are going to see the phasor on the power quality analyzer. Let us do the practical demonstration and see what is going to happen. As you can see now, the setup, our setup is here. You can see we have the wattmeter here. We have the auto transformer here. We have the power quality analyzer here. We have the this ammeter here, and we have the resistor load bank here. So first of all, as you know, we have given the input supply here, that is through the auto transformer. I can vary it from 0 to 220 volt. You can see the voltage here. When I am increasing the auto transformer voltage, you can see the voltage is increasing as well. It can be varied up to 220 to 40 volts. I will keep it almost to 20 volts. So you can see I have kept almost it is 220 volts here through the auto transformer. Afterwards, you can see now you can see the wattmeter. We have 4 connections: M, L, C, and V. So already we have given the connections here. As you can see, the wattmeter connection is here. This is M and C. As you already know in the circuit diagram, M and C are shorted. We have shorted by this green wire. Then M goes to the mains through the ammeter. You can see it is going to the ammeter from here. This is L, and it directly goes to the load. You can see this L goes directly to the load. You can see it is going directly to the load. And then from V we have 2 connections. One will go to the input, that is here, and another one will go to the load, that is here. So this is the wattmeter connection. Now what we will do, we will give the supply, and we'll increase the load. We will see the phasor on this power quality analyzer. Also we will see the power on this wattmeter, as well as in the multiplication of B into A. So let us start the experiment. First, you can see this is our load bank, and I will switch it on. As you can see, the voltage is almost 220 volts. Right now I haven't given any load. If I will switch this, put this switch on here, that means I have increased the load. Likewise, these are resistances are connected parallelly inside, so the current will increase. I will give some load. You can see on the scope, you can see this is the voltage, and you can see also the current. You can see the voltage as well as the current. So also you can see here, this is the phasor V into I. You can see the cos phi is unity, so there will be no phase difference. As I will increase the current, you can see the amplitude of the current is increasing, but the phasor remains same. You can see here also the current is increasing. Look, current is almost 6. You can see here the voltage, also how much the current is almost 5.3 ampere, and the voltage is 12 volts. If you multiply 212 into 5, that will be equal to around 900 something. And you can see on the wattmeter here, this will give you the directly reading, and you can see it will because we have connected it vertically here, so you have to multiply. That will be almost same. You can see now the graphical representation between the voltage and the current. They are in the phase. This one, larger one, is the voltage. As you know, the voltage is 230 volts, and current is almost, that is 5 ampere. So this is all about this. Thank you.